Did you know that up to 35 of Claude Certified Architect Foundation's candidates fail their exam on the first try? Will you be one of them? Not if you prepare the right way. Let's see if you can answer these real questions from our practice tests. Question 1. You are deploying a research and write agent that loops through plan search, synthesize updated aux steps. In production, the web search tool intermittently returns 429s or empty payloads, after which the agent burns its step budget, reissuing the same query. The document API also times out sporadically, causing the agent to retry and occasionally write duplicate sections. You need to redesign the loop so it terminates predictably, only retries when recovery is likely, and never applies side effects twice, even if the model or network hiccups. Which control flow change best addresses these requirements with minimal model prompt changes? A. Raise max iterations and add a generic retry wrapper around all tool calls with a fixed retry count, so transient issues resolve while the loop proceeds. B. Insert a self-reflection step where the model decides if it is repeating itself before each tool call, skipping the call if it detects repetition. C. Refactor to an explicit loop controller that classifies tool outcomes and gates side effects. Treat tool results as success retriable terminal based on metadata. Apply exponential backoff, enforce a step budget and goal-achieved halts, and require idempotency keys with a commit phase for document writes using a write-ahead intent log. D. Cache all queries and tool outputs in long-term memory and skip any tool call whose inputs match a previous attempt, relying on memory lookups to avoid loops and duplicates. What's your answer? Take a moment to think. The correct answer is C. This question tests agentic loop control, explicit termination criteria, retry discipline, and safe side-effecting actions. The correct design uses an external loop controller with outcome classification, backoff, budgeted steps, and idempotent commit gating, which together prevent degenerate retries and duplicate writes. A common pitfall is relying on model reflection or generic retries without tool-aware semantics or idempotency, which fails under real-world transient and rate limit conditions. Question 2. Your MCP tool provision user orchestrates an IDP and a billing API to create users. When the IDP returns a 409 user already exists on the email field, your tool currently flattens the error to a generic internal, and the agent keeps retrying, burning quota, and creating duplicate billing attempts. Security requires not leaking raw upstream messages, but the agent must be able to decide whether to retry, prompt the user for a new email, or short-circuit billing. What change best aligns with MCP error propagation best practices so the agent can take the correct next step without exposing sensitive data? A. Return a 200-style tool success with result null and embed an error object in the payload code message so the model can parse it while avoiding MCP error envelopes. B. Map all non-2x upstream errors to a single internal code with a sanitized message and keep only the original 409 details in logs to avoid leaking PII. C. Emit a structured MCP tool error using the error envelope with a normalized code, e.g. resource conflict, retryable false, and a user action hint to choose a new email. Include redacted details field email and a cause chain that preserves the upstream IDP status 409 and code, e.g. user already exists without raw messages. D. Automatically retry the IDP call up to 3 times with backoff, and if it still fails, convert the outcome to a rate-limited error so the agent defers the workflow. What's your answer? Take a moment to think. The correct answer is C. This question tests designing structured, privacy-safe error responses and proper error propagation for MCP tools, so agents can take correct recovery actions. The correct answer normalizes to a stable, meaningful code, sets retriability, provides user action guidance, and propagates a redacted cause chain. A common pitfall is flattening or misclassifying upstream errors or hiding them in success payloads, which breaks agent planning and triggers harmful retries. Question 3. Your monorepo has apps web and apps admin plus packages shared. A repo-wide, require user-facing change description convention should load only when real source files under appsarc change, but it must never load for generated artifacts in appsarc generated or for storybook test files .stories and .test. Recently, the convention began triggering on appswebsrc generated schema.ts and appsadminsrc button.storytsx. How should you adjust the path-specific conditional loading so the convention still applies to app source, but cleanly excludes the unwanted subpaths while avoiding packages shared entirely? A. Move the convention into parappconfig's appsweb and appsadmin and keep its default applies to of src, so it won't consider other directories. B. Keep the root rule with a single include glob of apps.src and rely on .gitignore entries to exclude src generated and .stories files. C. Define a path-specific rule on the convention with include globs of appsarc and explicit exclude globs of appsesc generated .stories and .test. Evaluated from the repo root D. Use file type conditions to load only for .ts.tx changes and place a negated pattern appsesc generated directly in the include list. What's your answer? Take a moment to think. The correct answer is C. This question tests path-specific conditional loading with include and exclude globs to control when a convention is applied. The correct answer adds explicit excludes that override a broad include, evaluated from the repo root, so only the intended app source paths load the convention. A common pitfall is assuming .gitignore or negated include patterns are honored by the loader instead of using a proper exclude list. Want more questions like these? The full course contains 360 similar scenario-based questions. Why choose our course? Because we provide detailed, scenario-based questions with deep explanations for every single option. Get instant access to 360+ questions and 6 complete practice tests. Start passing today with our 100 success guarantee.